Before we go on to talk about subnetting, we need to discuss reserved IP addresses. Because not all IP addresses are equal and not all of them can be used freely. Some of them are reserved for specific use. For example, all zeros are used as a default route. All ones in binary format and in decimal format, it looks like this. They are used as a default broadcast. So in our previous lesson, we determined broadcast a bit differently, but you can always use this form for sending broadcast packets all once in a binary format and of course in decimal format. That's what this looks like. And then we have the loopback address range. Most of you are probably already familiar with the address 127.0.0.1, but actually an entire A-class range is reserved for this use. Then we have the APIPA addresses. APIPA stands for Automatic Private IP Addressing, and it's used when your computer is set to ask for DHCP parameters from a DHCP server, but can't really find a DHCP server, or maybe you're not connected to a network, so you can't get to a DHCP server, or it doesn't exist, etc., etc. So when your computer can't get an IP address any other way, it's going to assign an APIPA IP address to itself. Other than that, we also have 3 private network ranges. These are defined in the RFC 1918. RFC stands for Request for Comments, and these are the documents where you'll find pretty much all of known network and other computer-related standards. So the 3 ranges are 10.0.0.0/8. Of course, we've learned in the previous lessons what this means. So pretty much all of the addresses that start with 10 or which have 10 in their first octet are part of one of these 3 private network ranges defined in this RFC. The next one is 172.16.0.0/12. And now it's not that easy to differentiate between octets when we talk about this mask. So I'm going to show it here in binary format. This is not really correct because this would be /16 the way it's shown here. But it's correctly shown in this binary representation. So the first 12 bits of this IP address represent the network portion. So this range actually ranges from 172.16.0.0 to 172.31.255.255. So you can calculate that based on what we've learned so far and check if I'm right. But that's it. That's the second private network range. And the third one you've also probably heard of. It's 192.168.0.0/16. So all of the IP addresses that have 192 in its first octet and 168 in its second octet, and whatever they have in the other 2 octets, they belong to a private network. Okay, now let's talk about the difference between public and private networks, or public and private IP ranges. So these 3 ranges that you see on the screen right now, these are only meant for private networks. This means that these addresses cannot go out into the internet. So they're not routable on the internet. They shouldn't end up in the internet. So there should be no packets in the internet with any of these addresses in the source IP address field or destination IP address field. So these don't exist on the internet. How is this achieved? Well, by using NAT. NAT is network address translation, and it helps us translate our private IP addresses into public IP addresses that are actually allowed on the internet. So the private IP addresses we talked about in the past couple of minutes, they're not even allowed on the internet. So we have to use the public IP addresses. So we have to translate our private IP addresses. The reason why we need to do this is because there are not enough public IP addresses out there for all of us to have one IP address, one public IP address per device or per person. So we have to use private IP addresses in order to save public IP addresses. And then we use public IP addresses. For example, these 3 computers are going to use one public IP address to go out to this HTTP server or web server in this example. So this server is going to see all 3 of these computers coming from a single public IP address. So this is how that's achieved. We have a private interface on the router. This is the LAN interface, and its IP address is 192.168.1.1. And we've talked about this in the previous slides. The network part or the network portion of the IP address has to be the same in the entire network. So this is our private facing or private network facing interface on our router. And this is the public network facing interface, or the WAN interface, wide area network interface. And we're going to give it this address, 76.0.13.6. So this is definitely a public IP address. It doesn't belong to any of the 3 ranges we've talked about on the last slide. And it's not a reserved IP address, so we can use it freely as a public IP address. Now this computer, 192.168.1.5, is going to send a packet. And this packet has a source IP address 192.168.1.5. That's the IP address of this computer. And the destination IP address is going to be 85.202.9.3. That's the IP address of the web server. So when this packet reaches the switch, the IP parameters remain the same. And then when this packet reaches the LAN interface on the router, the IP parameters are still the same. They only change when this packet reaches the WAN, or the outside facing interface of the router. So the source IP address changes from the private IP address to the public IP address. And then this packet is routed through the internet, and finally, when it reaches the HTTP server only sees the public IP address, and it's going to be the same public IP address whether the packet is sent by the top computer or the middle computer or the bottom computer in this example. Now, when the server sends its response, its source IP address, or the source IP address of the response or of the packet, is going to be the IP address of the web server. So it's going to be 85.202.9.3, and the destination IP address is still going to be the public IP address of the router. So once that response reaches the public interface on the router, the IP parameters are still the same. It's only when the packet actually goes through the router is when it's NATed back into the private IP address. So, whoops, I went back. So this is what happens next. Do you see that? So the source IP address remains the same, but the destination IP address is changed from the public IP address to the private IP address. And then the router sends the packet back to the original sender, which is 192.168.1.5 computer.